When we have multiplication, we can use area model or length times width. So when I have this 2x times x plus 7, I know that one of these terms, one of these factors must represent the width. So I'm going to say that 2x is my width, that length there. And the x plus 7 then must represent the length. So this length here, we're going to represent that as x plus 7. So when I multiply this out, I'm going to distribute 2x times x, which is 2x squared, plus 2x times 7, which is 14x. And when I show this, I can show that the 2x times x is going to give me the 2x squared area here. The 7 times 2x is going to give me my 14x area here. Okay, so this represents the area. The answer to the multiplication is the area in our area model. So when we talk about algebra, we have expressions, relations, and equations. Now, equations are when we have one variable, and that's with an equals in there. That there is a specific x that solves this equation. We may not know what it is. We can guess. It happens to be plus minus, plus 3 or negative 3 will work. But there is one variable. There's a specific x that solves this. That's an unknown. So this must be an equation. Now this differs from relations in that there's an equal in relations, but there's two variables here. So these variables are connected or related to each other. So these are relations. And then an expression is just when we have x's, there's no equal, it doesn't equal anything. X here is just some variable, it can take on any value. So this happens to be just some expression. There's no equal sign. So expressions don't have equal signs. When we talk about equation solving, okay, when we talk about these equations, we can actually solve them. There's only really one rule for equations, and that is keep equations balanced. So we can do anything we want, but we have to keep equations balanced. What we do to one side, we have to do to the other side. So as long as we do that, we're okay. The goal is, though, to get x by itself. So if I'm going to solve this equation, I need to get rid of a minus 4, and I'm going to use an opposite plus 4 to get rid of that. But I have to make sure I balance the equation. I have to do it on both sides of this equal line. Okay, so I'm going to end up with 2x on the left side, and that's going to be equal to 6 on the right-hand side. Solving is undoing, so I'm going to undo the times 2 with a divide by 2, but it's also about balance, so I have to do it to both sides. So on the left-hand side, I end up with x. On the right-hand side, I end up with 3. And now that I've got x by itself, I actually have a balance that shows me what x is actually equal to. I've solved for x. So doing the same thing here, I've got a plus 4 to get rid of the minus 4. I'm going to plus 4 on both sides. That gives me negative 3x is equal to positive 15. If I want to get rid of a times by negative 3, I'm going to divide by negative 3. But I have to balance. I have to divide both sides by negative 3. I have to keep track of my positives and negatives. Negative divided by negative gives me the positive x, which is what I'm looking for. 15 divided by negative, positive divided by negative is negative. 15 divided by 3 is 5. So here I've kept it balanced. That's my only rule. By keeping it balanced and getting x by itself, I've now solved for x.